Section 1.4 is dealing with more properties of functions. The next property we're going to be looking at is where is the function increasing, decreasing, and where is it constant? If we look at the very first graph listed here, when checking to see where it is increasing, decreasing, or constant, you always have to read the graph left to right. Start at the leftmost side of the graph and work your way to the rightmost side. Okay. And then as you're finding your answers of where it's increasing, you're always writing it in interval notation in terms of the x values. So interval notation with x values. So our first graph, the example, as we read it left to right, beginning at the left-hand side, what is the graph doing? Increasing. Does this graph ever stop increasing anywhere? No, so it's increasing the whole way. So we would say that's increasing from negative infinity to positive infinity. The second graph, reading it left to right, what's the graph doing? Decreasing. Does it ever stop decreasing? No, so it's decreasing negative infinity to positive infinity. The third graph is doing what? It's remaining constant the entire time. So that's constant from negative infinity to positive infinity. And the fourth graph, left to right, starts here and it's doing what? Decreasing. It's decreasing. Now we have to look at the x values. So if we drop that down, what's its x value? Or actually, it's continuing on. So that would be what? Negative infinity up to negative 2. Okay. So decreasing from negative infinity to negative 2. Now what's the next thing it's doing starting at negative 2? It's constant. So it's constant from negative 2 to what x value? Positive 2. And then starting at positive 2, it is increasing. Okay? Increasing on 2 to infinity. Now notice they were using brackets. Really, it doesn't matter whether you use brackets or parentheses. Most of the time when I am writing my intervals, I will always be using parentheses. Okay? So I will use parentheses in my interval notation. Correct. Correct. Okay? Because a lot of times where there's a point where it changes, like right here at negative 2. Well, it was decreasing, getting to that negative 2, but then all of a sudden from negative 2 on it was constant. So how can it be doing both things at once? So that's why I'll use parentheses. Okay, if that makes sense. All right, questions on that? Then let's look at an example. We're going to be talking about the increasing, decreasing, and constant, but we're also going to talk about maximums and minimums. Maximums and minimums. So when you see the word extrema, extrema means extremes, and so that means maximums and minimums. Extrema means you're looking for your maximums and your minimums. Now with maximums and minimums, we have two types. We have relative maximum and minimums, and we have absolute maximum and minimums. An absolute maximum or minimum means that, let's say if we're talking absolute maximum, no other point ever anywhere else on the graph will ever go higher than an absolute maximum. That's why we're so firm with the word absolute. Nothing ever goes higher. Or if we're saying absolute minimum, then no point on the graph ever goes below that absolute minimum. Okay? That's different than relative maximum and relative minimum. Relative means within an overall graph, at some point it might reach a peak and then come back down. But then it has an arrow that goes off to positive infinity maybe. So relative to a certain area within the graph, it reaches a maximum point, but it's not an absolute maximum. Okay. Or with relative minimum within the graph, let's say it came up to a relative maximum, and then it comes down to a little valley, and then goes up. Well, that's relative to that area of the graph, it reaches a minimum. So we call that a relative minimum. Okay? So let's look at this graph that we're given, and we are going to find where it is increasing, decreasing, and where it's constant. And then we're going to find maximums and minimums. So let's first start with increasing, decreasing, and constant. We read the graph left to right, and it's always in terms of the x values. So starting at the leftmost part of the graph, what does the graph begin doing? It's increasing. Where does it begin increasing at? Okay, so increasing negative infinity to what value? Negative 2. So here it makes a change, and that's at an x value of negative 2. So negative infinity to negative 2, it's increasing. Now at negative 2, what's happening to the graph? It's decreasing. So on my decreasing line, it starts decreasing at negative 2. Where does it stop decreasing at? At positive 2. So here's the next change, and that's happening at positive 2. Now what change is made at positive 2? It's going back to increasing. So back up with my increasing line, we're going to put union 2, and then it increases from 2 to what? 2 to 5. Because 5 is the next x value where it stops increasing. What's happening now at 5? Okay, now it's decreasing. So go to your decreasing line, union 5 to what? 6. Now around the 6, that is a very specific closed circle. So what should I put there? A bracket. When it is a closed point and it's coming to a stop with the increasing, decreasing, that's one area we would put a bracket. Okay? Now, what's happening else starting at 6? It's increasing. Okay? It is increasing. But there, notice with this 6 down below, it is an open circle, so that has to be parentheses 6, and increasing to 8. What's happening at 8 though? Hang on. It's still increasing. So it's really increasing from 6 until infinity. Was it ever constant? No. So constant, we're just going to write never. Okay, so now let's look at this. And let's talk maximums and minimums. What about absolute? Does this graph have an absolute maximum? No, why not? It's going to infinity. It has the arrow showing it keeps on going up and up and up. Does this graph have an absolute minimum? No, why? It keeps going down to infinity. Okay, so no absolute maximum or minimum. So now we need to talk about relative maximum and relative minimum. So relative max. Do we have a relative maximum where local to a certain area it actually reaches a peak?
Yes.
Okay. Chewy, where's one?
5,
-2, 5. -2, 5. That is a relative maximum. Okay. Joseph, is there another? Where? 5, 9. 5, 9 is also a relative maximum. Relative to this area of the graph, it reaches a peak. Okay. Let's see. Shanae, are there any other relative maximums? That is correct. No, there are not. So now let's talk relative minimums. Okay, relative minimum. Let's go with Emily. Do we have one? Okay, 2, -3. 2, -3 reaches a relative minimum. Relative to that area of the graph, it reaches a valley. Okay, Chase, do we have another one? Where? 6, 4. 6, 4 is a relative minimum. Relative minimum because it's a closed dot. No other part of the graph at that location is going lower. Okay. Do we have any others? Maybe. Well, let's see. Let's look at 8, 3. Does it come to a distinct low point? No. It's increasing and it just goes right through that point and continues increasing. So no, that would not be a relative minimum. So do we see any others? Okay, so let's look at 6, 2. It almost looks like it should be a relative minimum, but what does an open circle mean? It can't equal that point. So if it can't equal that point, it cannot be a minimum. Okay, so that is not a relative minimum. Any questions on that? Okay, let's look at the next piece. Absolute value reflections. If g of x equals the absolute value of f of x, then any portion of f of x that is below the x-axis is reflected over the x-axis. Okay. So here we have a function, and actually I think this should say if f of x. If f of x equals x squared minus 2, sketch g of x, which will equal the absolute value of f of x on the next axis. So this is our function f of x. The function is x squared minus 2. So what is this point right here? 0, -2. Okay. Now think about if you did the absolute value of -2, what does it become? +2. So instead of being down there, it's going to be up here. Any part of the graph that is below the x-axis will be reflected over the x-axis. Now what's important to know is your zeros stay the same. Everything above the x-axis stays the same. It's just the bottom part is reflected over the x-axis. Okay, so first thing I would want you to do is find your zeros on the original graph f of x and then plot those same points on your new grid of where you're going to be doing your absolute value graph. The portion of the graph that is already above the x-axis will stay exactly the same. So we need to go ahead and draw that portion on our new graph. They will stay exactly the same. But instead, it's this portion, anything below the x-axis is going to get flipped up. It's going to get flipped up. So instead of that point being down at 0, -2, it's going to be up at 0, +2. And so it'll look kind of like that. That is how you will do an absolute value graph. Always start by plotting the exact zeros from the original function. Second step, always take everything that's already above the x-axis and draw it exactly the same on your new graph. Third step, flip whatever is below the x-axis to above the x-axis. Okay, that's it. Any questions? Say again? First step is the zeros, identify the zeros and mark those on your new graph. Zeros stay the same. Okay, other questions? All right, let's flip it over. Example 1. Use the graph of each function to estimate the intervals on which the function is increasing, decreasing, or constant. State the extrema, determining relative or absolute, and write the extrema as ordered pairs. So the first graph A, the equation, or the function, is -x⁴ plus 4x² minus 1. So let's build our list. We need a portion for increasing and decreasing and constant. And then over here on the side is where we'll do max and mins. Okay, so increasing, decreasing, constant. Always read the graph left to right. So starting at the leftmost part of the graph, what does it begin doing? It's increasing from what? -∞ up to, okay, let's be careful here. It's, this number here is -4, that right there is -2, so it's a little bit less than the -2, so but -1.5. There you go. Now what's happening at -1.5? Decreasing. So decreasing line, -1.5 to what? Remember, it's an x value. You're doing your x values, and it stops decreasing right there, so that's at 0. At 0, now what is it doing? Increasing. So union, increasing 0 to what? Looks like that's about 1.5. And at 1.5, it's then what? Decreasing 1.5 to infinity. Good. Constant? Never. Positive infinity, because remember, we're doing x values. So bigger than 1.5, continuing to go out, is positive infinity. Negative infinity for the x values is on the far left side of the graph. Okay. You're welcome. It's always for the x values, yes. Other questions? Now let's talk max and mins, relative and absolute. What is it you noticed? Do you see anything? Do we see maximums? What kind are they? or absolute? Are they at the same level? Yes. So we have absolute maximums at, we have to write it as an ordered pair. What's this first one at? Negative 1.5, comma, what y value is that? 3. Good. And we have another one. Where's the other one at? Positive 1.5, comma, positive 3. So the y value there has to be the exact same in order for it to be the absolute max for both. Okay, so that took care of that point and that point. 2 absolute maximums. Do we have anything else? Any other extrema? We have a minimum. What kind of minimum is this going to be? Relative, because it's local to that certain area. There are other points of the graph that are going lower. So that's why it is a relative minimum. And the relative minimum is occurring where? Good. Connor says 0, negative 1. So 0, negative 1. That is correct. Questions? Yes, Lauren. Okay. Absolute maximum. You see how they're both on the same level? Okay. Does any point ever go higher than this point? No. Does any point ever go higher than this point? No. That's why they're both absolute maximums. Okay, Emily? Because it's reaching a valley, it's dipping down instead of doing a peak, like a mountaintop. So it's dipping down. So since it's dipping down into a valley, it reaches a little minimum point there. Okay. Good questions. Do we have any others? Yes. Yes, correct. Then after that, you just figure out, is it an absolute or is it a relative? Anything else? Excellent. What I want you to do on part B, the graph here for h of x, I would like for you to do this one on your own. Find where it's increasing, decreasing, constant, and then find and state any extrema and whether it's relative or absolute. Okay. All right. Maximums. There are no maximums on the graph. We could say there is an absolute minimum at y equals negative 1, and it's going from the point 4, negative 1 to the point 7, negative 1. It stays at that absolute minimum the entire time. Okay. All right, so any questions on that? Again, it was never increasing. It's decreasing the entire way from negative infinity to 4. It doesn't matter that the slopes change. It still decreases during that slope changing. And then it was constant 4 to 7. Lauren?
Is there any kind of minimum, like not for the first line, it's for the second one on the bottom, that's like under it, but it's still in.
Yes. Yes. Correct. All right. Let's now look at example 2. Estimate and classify the extrema for the graph. Sketch g of x, which will equal the absolute value of f of x on the same set of axes. So first let's do our extrema. Do you see anything that's absolute? Is there an absolute maximum? Okay. Is there an absolute minimum? How come there's neither an absolute max or min? Perfect. It's going to negative infinity on one side, it's going to positive infinity on another side. Okay, so no absolutes. Do we have any relative maximums or minimums?
Yes.
Okay, so let's talk relative max. Does it ever come somewhere in the graph to a defined peak?
Yes.
Yes. Okay, so now we need to estimate where that's at.
That is 2.
Looks like it's at 2, 0, right there. So we're estimating that to be the 0.20. Do we have a different relative maximum? Okay, so let's look and see at 0, 0. It's like it has the cubic function tendency right in there. It is decreasing the entire way, and so it's not really coming to a defined peak. Okay? It needs to be coming to a defined peak in order to be a relative max, or even a relative minimum. So there at 0, 0, where it's making that little curvature change, it's neither a minimum nor a maximum. Okay? So do we have any other maximums? No. Do we have a minimum? Yes, we do. It's a relative, because we already said there's no absolute. Where is that relative minimum located? Maybe about 1.25, because notice how it's in, the graph is broken up to. This is a 1, which means this is 0.5, and this is 1.5. So it's between the 1 and the 1.5, comma, what? What could we say? Negative 1.2, roughly, because it's dipping down below a little bit. Okay. Do we have any others? No. No. Okay, now we have to draw the absolute value graph, the absolute value of f of x. And we're going to do it on the same grid. So what's the first step that I said we have to do for absolute value? Same zeros. So find all of our zeros, and they have to be exactly the same. The portion above the x-axis has to stay exactly the same. Okay. So that has to stay exactly the same. The portions below will get flipped over. So let's look at this here. It was at negative 1, or at 1.25, negative 1.1. So that gets flipped over to 1.25, positive 1.1. So we can draw that portion. And then that part, instead of it going down, it needs to go up. So from that 0, going up. Well, do you see how you do that absolute value graph? Do you have any questions about it? Okay. Example 3. For example 3, we're going to use a calculator. So if you will, grab a calculator, whether you have your own or if you need to borrow one of mine, and then go ahead and type in that first function. So we're graphing the function 3x cubed minus 6x squared plus 8. Three x cubed minus 6x squared plus 8. And if you do zoom 6, it'll just put it on a standard viewing window. Okay, so this is the graph you should be seeing. The directions on example 3 say graph the function with your calculator and estimate to 3 decimal places any extrema of each function. State the x values and specify whether the extrema is relative or absolute. So we're putting it as ordered pairs. Okay. Now, are you familiar with how to find maximums and minimums using the calculator? Yeah, you think so? Let's give it a shot. Let's do the maximum first. So we're going to do second trace, pulls up the calculate menu. We want number 4, maximum. This is the area where our maximum is, so we need to move the cursor to the left of it, enter. Then it says right bound, so move the cursor to the right of that peak, enter. For guess, just enter again. Now notice what my calculator gave me. 1.0324 e negative 6.
I got 3.42.
Okay, but you see how it has the e? That just means it's 0. Sometimes the calculator will actually spit out 0, sometimes it won't. So just look for the e, and if you have e to a big exponent, the value is 0. Okay, so for the x value, we put 0, and the y value is 8. So we have a maximum. Now, is it going to be a relative or an absolute? It's relative. We have a relative maximum at the point 0, 8. It's just each calculator is a little bit different, and the algorithm and calculating it's a little bit different. So, yeah. One of the quirks of the calculator, just like it won't show the whole unless we do zoom decimal, or just like in some instances it doesn't show the vertical asymptote lines continuing in both directions. So the calculator's quirky like that sometimes. Do we have any other maximums? No. Do we have a minimum? Yes, so let's calculate the minimum. Second, calculate or trace. Minimum is number 3. Now I move the cursor. I'm going for the valley, so I move the cursor to the left of the valley, enter. Move it to the right of the valley, enter. Guess, enter again. So 1.333, comma, 4.444. Is it absolute or relative? So it's a relative minimum at 1.333, comma, 4.444. Any questions on that? All right, on your own, type in that next equation and find all extrema on your own. So for that equation, negative x to the 4th plus 3x cubed minus 2, do we have any extrema? Yes? What kind do we have? You have an absolute maximum where no other point ever goes any higher? Perfect. So the absolute maximum is where? 2.250, comma, 6.543. Perfect. Is there anything else? No. No, there was nothing else on that graph. Okay, excellent. Example 4, sketch a graph of a function where it meets each of the different criteria. You're going to do these on your own. You're going to give it a shot and try it. On the first one, I want you to come up with a function f of x that is continuous and always increasing. Go. Function that is continuous and always increasing. For that one, what could we draw? A straight line. There you go. It's continuous. It is always increasing. The second one now I want you to try. The function is continuous. It's increasing for x values less than negative 2. And it's decreasing for x values that are greater than negative 2. Question? Mm-hmm. Remember, you're reading the graph left to right. You're always reading it left to right. And so starting at the leftmost side, even though I have the arrow there, it's increasing as we're reading it left to right. Okay. So on B, it needs to be continuous. It's increasing for x values that are leading up to and less than -2, and then it's decreasing for values for x that are greater than -2. Okay, who would like to share what they did with that one? Emily?
I went straight to exit
Did you do something like that? Excellent. You could have done that. You could have done an upside down parabola that increases up to the -2 and then goes down. That would be fine as well. Did the point have to be on the x-axis? No, it didn't. I could have put it up. I could have put it down below. It's increasing and then it's decreasing. That's just the point of where it changes. Okay. Now try the last one. The last one, we need a graph that has 2 relative maximums and 1 absolute minimum. Absolute minimum, one of them, and 2 relative maximums. Give that. I saw a lot of good examples of what you did. Here's an example I'd come up with. So I have 1 absolute minimum, and I have 2 relative maximums. Okay, and I saw in your papers you had a lot of things that were somewhat similar. So it has a whole bunch of peaks and valleys in it. Okay, any questions? Perfect.